check to make sure that's a cap. Oh, I need a pokey device. One pokey device. I didn't pull these off before. The little extra coupling tabs. Since I'm here and things are hot, might as well pop them off quick. So I'm just adding a little bit of solder to all the connections just to help make a better connection between the desoldering iron and the pins to get the heat to flow through. Right now the little bit of solder on there isn't flowing real well, so when I go to try and suck it out, I'm just sucking the surface solder, not sucking it all the way through. So this time you see I got a nice clean hole there, where before I was just sort of getting, well, not much of anything. Like that one. I'm guessing that's a power pin. My solder sucker's getting plugged up. I have to clean that quick. First, let's see if I can knock that chip out. I'm guessing not. Although I got all the stuff off the backside, the heat did not transfer through evenly. And there's still solder connections on the top side. Yep. That is an X chip now. Right there's the die, or was the die. And here you can see they had a power connection to pin 1 and no connection to pin 2. So that last gate on this buffer was not used. Well, I can see a little bit of light through it. No big booger in there, so let's just get the tips plugged. There you go, let's give that a try again. I'll make all 3 pins. Well, that works too. There's the reason why I'm having so much problem. There's a big tip on my solder sucker has degraded to the point there's a big hole in the side. Couple different ways to fix it. Easiest one's just to replace it, but let's see if I can get lucky and just file the tip down to the point where there's still material all the way around the edge. There you go. Downside to doing this is now the tip's fatter, so it can't get into as small places. But hopefully I can eke enough life out of this tip to finish up the project for today, or my reverse engineering for the day, because I don't know if I have a spare one in my kit of parts, which means I'd have to wait until I could order some, and they came in before I could use my solder sucker again. But so far for this, relatively big pin through hole stuff, it seems to be working, so keep on going and see how far I make it. So what I'm watching for here is for when the solder melts on the top side of the card, and then once it melts, turn on the suction and wiggle it back and forth until I clean the barrel of solder. When I did this the first time, I thought I was there, but I was definitely wrong, because I certainly was not. So, not pretty on the tip of the solder sucker, but as you can see, as bits and pieces of this fall on the floor, it sort of did the job. Still have one pin stuck in a barrel there. Boy, did I ever booger that up. Well, it's a good thing I don't need this part, because I totally destroyed the pads on the backside. As you can see, all these pads are ripped off. Those two are still there. That one's gone, most of that one's gone, that one's gone. Which is pretty typical on some of these older cards. The laminate gets old and the adhesive that holds the foil to the laminate gets old, and then it just starts delaminating as soon as you put some heat to it. So as to the question what this guy is, I'm pretty sure it's just a cap. And I'll be able to find out in a second here. Value. 1.6 picofarad cap to be precise. Ooh, negative. Hold on. Okay, so my closed off like this, my leads say 0. So I'm calibrated. One thing this could be is a resonator, but man, I've never seen a resonator in a crystal circuit like that. It's not ringing out like a cap. You know, as you could see when I was testing it on the Sencor, I got a negative value, which is not normal. So, you know, if I hit one of these little ceramic decoupling caps, you know, I get 9,000 picofarads, which is about what I expect for them. And these guys marked to their value. Not really. You know, here's another one. So, you know, I know my meter's working. 28 picofarads, yeah, that's reasonable for a ceramic disc cap. Here's electrolytic. 12 volts DC. I wonder if that 1-12 means 1 microfarad. .4 microfarads. Probably within the tolerance. So, you know, my meter's not totally off. So if anyone knows what these little, you know, it's 10 plus or minus 5%. So I'd assume that would be either 10 picofarads, 10 microfarads. Oh! I wonder if I just have a bad connection. Or that was just me being... Well, it's... Oh, is it an inductor? I wonder... That's a pretty high value for an inductor. Just leave that on for now. Nope, don't think it's an inductor, because typically with inductors you'd get, you know, you'd see the short between terminals in resistance. So I think this was a cap, 10 something plus or minus 5%. Now this sign didn't work, so you know, this could be the problem. If the main oscillator was dead, that totally explained a lot. But anyways, let's move on. So time for Senor flip-flop. So I don't need that anymore. I do need this. So pin 1 is clear on the flip-flop. So pin 1's right there, and it is hooked to power ground. Let's figure that out, because that's gonna power. So pin 1 is high. Pin 2, I don't see the connection to it. What is pin 2? Pin 2 is data. I'm pretty sure there is a connection to that. Pin 3 went to the cap, you know, went inside the os. You know, that's pin 3.